We've all been there before. You go into the office only to find all your business intelligence dashboards broken because data is running late. There were ETL delays either earlier that morning or on the previous day, and because of that, all of your downstream reporting is broken. So how do we get ahead of this? Today I'm going to show you how to build a Python automation that loops through all the tables in your database and returns only those tables that have latent data. So here we are in MySQL. Again, we're using the mobile games database, and here are all the SQL tables in that database. So what we are going to do in Python is loop through each one of these tables and loop through each column in each table, looking for any column that has dates in it. And what we're going to do is we're going to take the max date and see if that value is on time, meaning the data is updated, or if the data is late. So in most data environments that I've worked in, data is updated if it's through the prior day. So today's date, or the date of this recording, is September 8th, 2024. So updated data would be September 7th, 2024. So if the max date in the table is anytime sooner than September 7th, 2024, we know that data is late and we can flag that table. Let's go ahead and start building this process in Python in Visual Studio Code. Okay, the very first thing we need to do is import all the right modules and packages. So let's do that now. Okay, the very first thing we need to do is figure out what date represents data being fully updated. So as discussed, we're going to go with prior day. So today is September 8th, so we'll say that if the max date value in these SQL tables is September 7th, then data is updated. But let's get that September 7th date and put it in a variable for us to use and for us to reference in this process. So we'll say prior day date equals date time now, which is going to be today, September 8th, 2024, minus, let me spell that correctly, minus a day. Okay. We will call this retrieving prior day, prior date. Fantastic, that looks good. Now we need to return my MySQL password so I can successfully connect to the database from Python. And again, the password is stored in an environment variable, meaning we'll be able to use the password, but it'll remain hidden in the environment variable. So super conducive to utilizing a password, but not exposing the actual value of it. Let's establish a connection to MySQL. So we'll call this connect to MySQL. This will be the connection variable. The password is going to be the environment variable. The database will be, again, the mobile games database. This needs to be in quotes. Okay. So as we loop through these tables and loop through these columns and checking for the max date and seeing if any tables are late or have latent data, we need to take that resulting information and store it somewhere. So we're going to store it in a pandas data frame. And then from that pandas data frame, we're going to send a copy or save a copy to our local machine as a CSV, and then send another copy back to MySQL so that yourself, your team, ETL architects, and data engineers are all aware of what's going on and aware that there were ETL issues. Okay, let's get started on that. We're going to call the data frame data latency detection. Let's define it. Columns. So we want to know the table name of the data source that is latent data, the column name, or the name of the date field, okay. So data through expected, that's saying our data should be through September 7, 2024. So that date is going to be in that field. Data through actual is what the actual max date is, and it's going to be less than that date, meaning, hey, this table is late, we're having a data latency issue, you're going to have to rerun ETLs. And then the days late is, how late is this data? 1 day, 2 days, 3 days late. This is basically just a little bit of simple math or subtraction between those two fields. Okay, so let's start getting our data. To do this, we're going to have to create a cursor object. And we're going to be using this connection up here. So connection.cursor. We can just call this variable cursor. It's fine with me. Okay, we're getting there. Let's return all of our tables. And this is a command that Python is basically sending to MySQL to execute. And it's going to be show tables. Now all the tables will be shown. We need to save that somewhere and save that ideally in a variable. So we're going to fetch all that data. Tables. Save it in a variable called tables. Now we need to loop through each element or each table, and then on each table loop through each column. So we'll do for table in tables. So for each element, for each table in this list of tables, so for each table we need to, again, return all the columns and then loop through each of those columns. So we will do something similar like we did earlier, but do it for columns. So it's going to be a cursor execute command, and we will use an F string for this, and it'll be describe. We've got to add the table name. Okay. Great, that's going to return all the columns for that specific table. So we're going to use the same command to return all of those columns. It'll be the same fetch all command, but we need to save it somewhere. So we're going to say columns equals and this command is going to return all columns, including columns we don't need. So we need to filter these columns now just for date columns. And we need to make a distinction between date columns and date time columns. We only want date columns for today's workshop. So now we're going to do a Python list comprehension and loop through each column and only keeping those that are date fields. So we'll do in if we're looking for the string date in the column name, in the column name. Remember, both the table name and column name is stored in index or position 0. So what this is saying is we have all these columns. They were stored in the cursor fetch all. Now for each column, if the string date is in the column name and it's not date time, then keep that column. We can call those columns filtered. So if we didn't add this portion here, it would return columns that both say date and date time, and we only want date. So that's why we had to do a logical and. So let's do another loop. And we're going to use another cursor execute statement to submit some SQL to MySQL to run. Okay, let's just do a quick review of what we did. So for each table, we're looping through, or we are returning all the columns. And then we're only taking columns that have date somewhere in the column name. And then taking a max of that column from that specific table and having that value returned to us. So if you remember, one of the SQL tables called fact player login, and the date field was called login date. So as you can imagine, what this is taking a max of the login date field from fact player login and returning the result to us so that we can check to see, hey, is that max date value yesterday's date, or is it older than that? And because of that, a table that has latent data. So let's declare a variable, result equals the same fetch all. So now what we can do is we have the date value we need. So let's do a couple of formatting changes and get it where it needs to be. Let's do date time. Let's add some formatting here. And we can call this max date. Okay. And now we're going to run our logical check to say if this max date is older or earlier than prior day date, then we know that this is old or latent data and it needs to be flagged and it needs to be saved into our pandas data frame. And now we're going to define the fields that we'll be inserting as records into our pandas data frame. So we can say data through expected. Going to be the prior day date. We need to do some formatting changes so we can prepare this data to both save it locally on our machine and also send it to MySQL. Okay, so this is the actual max date value for our SQL tables. So it'll be max date, same thing. And then days late, which is another field that's going to be inserted into our pandas data frame. It's just going to be a little bit of arithmetic. Let's grab this. And we're subtracting the 2, and we want it to be in increments of days. Okay. And now let's insert these records into our pandas data frame. Data latency detection. Let's take the length. So we can find the first open or available record where rows can be inserted. And we want the table name. So remember, that will be this. We also want the column name, which is the same thing. We want... So we're expecting the data to be through yesterday, September 7, 2024, but unfortunately it's actually going to be older than that. So we'll do the data through actual, and then we'll do how many days late is our data. Okay. So that's done. Now we need to figure out where do we want to deliver this data or deliver this pandas data frame. So let's save a copy to our local machine as a CSV. So we'll do that now. So data latency, let's call this save locally as CSV for reference. Data latency detection to CSV. And I will save it to my own local file path, users. Just so you can see a real example of how this works. Index is going to be equal to false. We don't need any numerical values ascribed onto any of our rows. Now we need to send this pandas data frame back to our relational database or MySQL because it gives visibility not only to yourself, but to other people on your team, people in your department, and also for the data engineering team and the data architects that are refreshing your data sources in your database, or in today's case, a mobile games database. We're going to have to establish a slightly different connection to MySQL to gain write abilities, meaning us sending data and writing it out to MySQL. Okay, the user is going to be root. And then we have to add our MySQL password. That's going to be our environment variable, which is up here. And then our database that we're working in, again, is our mobile games database. Great. Let's check our work real quick. MySQL connector. The user is root. We have our MySQL password as the environment variable. And then we're connecting to the mobile games database. Okay, now let's send this to MySQL. So when we send this pandas data frame, basically turn it into a SQL table, and we want that SQL table to be called data latency. The connection is going to be engine. If that SQL table already exists, let's just replace it. And then the index equals false, as we did above. And then after we run all that code, let's just print, congratulations. So let's run this now. Okay, so this wouldn't be authentic without a little bit of troubleshooting, so let's dive in. We actually need to get the column name right here. Since we are returning just one date, a max date, instead of fetching all, we just need to fetch one. One more thing we need to do is we actually have the data latency CSV already open, or at least already open on my machine, because I want to show it to you. So because of that, I'm gonna have to comment this out, but we will still be saving this data out to MySQL in the form of a SQL table. And there we are, congratulations, right there. Okay, now let me show you the value of this automation. Okay, so here is a copy that we save locally on our machine. It's pretty cool, right? So it shows you all of the tables within your database that have old data or latent data. It shows you the date column that you use in that table and the max date, which is September 5th. And as you can see, we should have had data through September 7th, yesterday prior day, but we only have it through September 5th, meaning this data is 2 days old. So this is pretty cool to have. And then, most importantly, I'm going to show you this exact same data, but in the form of a SQL table. So you can see here that a new table, SQL table, has been added to our database. It's called data latency. So let's take a look at it. Here's the exact same data. It shows you all of the offending tables that doesn't have updated data, that has 2-day-old data. So I think this is actually a pretty cool method to stay on top of dirty data or late data by using that Python automation. Thank you very much for joining today's session. Please continue to like and subscribe.